Okay, now it's recording. Hello, Professor. Today our project for the big data is we're going to predict whether the customer will default in the next month or not. So our data set is default of credit card clients teams data we have gathered from the UCI repository. So these are all my team members. We are group of 5. Our contribution is each these are the activities we have segregated the activities based on each team member. For example, Akshay has done data pre-processing, feature engineering, data collection, and Mukesh has done model building, metric collection, and data pre-processing. So now I am handing over to the uh, Vijay Tej. He will continue.
Yes, Professor. Coming to the problem statement, we used collection of the client attributes and the past credit card payment records in order to develop a predictive model capable of effectively distinguishing whether the credit card holder will fail to make their payment or not. So, since our primary objective is revolves around the constructing a robustic machine learning model, so we have done an analysis by using calculating the metrics such as accuracy, precision, recall, F1 score, and ROC so this analysis aims to determine the model capacity to accurately anticipate instances of the credit card defaults, ensuring that it provides a holistic understanding of the predictive performance. So the dataset is often used for research analysis and model development to gain insights into the factors that influence the credit card default, and also to build predictive models which can assist the financial institution in risk management and decision making. Why is it worth solving? These are the parameters which we have considered, such as risk management, enhanced customer experience, cost savings, data driven intelligence, and economic ripple effects. Risk management means yeah, problem solving. We have used the data analysis and modeling, such as logistic regression, support vector machines, random forest classifier, decision tree classifier, multi layer perceptron, and evaluating the solution. I have already mentioned these things.
Now we are going to my another team member Srikanth. Srikanth will handle from the data description part.
Yeah, hi, Professor. So basically, the data description over here, we collected the data from UK machine learning repository. So overall, our data sets has more than 30,000 data points featuring. So it has 25 different sets of variables, as you can see. All this ID, limit balance, and sex education and everything. So all these are independent variables. Uh, So only this, the last, this is the variable we are going to create, that's a dependent variable. Based on those variables, we are going to define this. Next slide.
Yeah, Srikanth will explain this data model, like it just what we have done until now for the big data project.
I can't see the next slide.
Yeah, right now we are in the data
Yeah,
model. So what we have
yeah,
done is like we have started Pyspark session. After that, we have imported data and done some data pre-processing like cleaning. And after that, we have created some features, so-called feature engineering. After that, we applied machine learning models. We have applied like 5 machine learning models, and based on our metrics, evaluation metrics like accuracy and F1 score, we have predicted which model we have assessed which model is best for the given data. Now going to the code. So this is what the code looks like. First, we have started the Spark session as previously mentioned in the assignments. I have called the Spark session, and after that, I have imported the data. I have this data is present in the data folder, which is present in week 10. After that, once we have done the imported the data into the data folder, we have already also sent the data to the data warehouse. Uh, the code for the adding data to warehouse is like here. As we can see, we don't have previously I mean credit card default here. After that, we have write the code and send the data to the data warehouse. After that, we have used basic SQL operation to see what are the top 5 rows present. I mean, like what are the columns, and just querying the database with the basic SQL code. So after that, we have started the data cleaning process. So luckily, we don't have any null values. If there are null values, you can easily remove that one. So after that, I tried seeing like in the basically the data has some categorical columns like sex, education, and marriage. So first we have converted this into the numerical columns. Also changed the column names to pay 0 and pay 1. So after that, we have done like some data exploration just to see what the data contains. As you can see, single man has most data points when compared to marriage and the others. Also, we have done a pie chart to see whether y- which education part are the most people defaulting each year. So these are 46% of the 8 point data points are present in the data set. So like this one, we have done different explorations. After that, I have done like what is the distribution of the age using the histogram plot. So once the data exploration part is done, what we have done is we have done future engineering. Uh, le- let's wait for a second. I will go to the future engineering part. Yeah, this is the feature engineering part. Here we don't have any new features that can assess the model that the model can easily to predict whether the customer will default the next month or not. So we have done like creating new features like using the marriage and age, I mean sex of the people. We try to create new features. So after that, we have segregated the age column into different bins. As you can see from the plot, uh, this one belongs to the age group between 20 and 30. So like this one, we have segregated data into the bins. So after that, we have created new features like average expense for the each person present in the data set. Also, we have based on the bill amount, we have created this average expense for the each data point. So once this is done, we have gone to the final part of the feature engineering, which is the unbalanced target variable. We only have like 6,636 of people who are defaulting and more than 20,000 which are not defaulting. So we have used one technique called SMART, which will balance both the classes. We have tried like oversampling and undersampling, which is not good for the data set because it will become bias for the machine learning to predict the whether the customer will default or not. So because of this, we have used the smart function. After that, I'm going to the machine learning models. So now I am handing over to the my friend Mukesh. He will take in from here.
The the features from the feature engineering, we first split the data into training and data test data. Then after that, we have created machine learning models like based on uh, five different algorithms like random forest, logistic regression, decision tree, and MLP classifier. So for the each of these models, we calculated predictions for the test data, and based on the predictions that we got, we have evaluated different metrics like accuracy, precision, recall, and area under the curve, AUC. So for these, we have created two functions. One is matrix, and other one is the curve. And whenever the predictions are sent to these definitions to these functions, we get the different classification metrics, and all these classification metrics have been concatenated into a Spark data frame, which we can see at the last. So this is the yeah go down.
Just a second.
Yeah, this is the Spark data frame that shows different metrics. And now I'll be handing over to Kaja again.
Hello, Professor. The challenges faced while doing this project is within the domain of future engineering data. It's challenging to definitely determine which category of people are more disposed to default on loans, like whether married men or married women. So consequently, a new feature has been constructed to pinpoint which demographic category is at high risk of experiencing loan defaults. So this process has established a category for married men anticipated to have higher probability of defaulting. Additionally, it combines married women and single men into another category, representing a potentially less populated group denoting divorced men. So there are also distinct categories for single women and divorced women. Moreover, an analysis of the target where a label reveals an imbalance in the default payment column with both classes unevenly distributed. So three approaches were considered to address this problem: increasing the sample size of the lower count class through upsampling. Also, we done downsampling, which involves reducing the sample size of the higher count class. And so we finally opted for the smooth algorithm to generate synthetic data. Our choice leaned towards smooth because it has given the best output. So this method introduces a degree of randomness in crafting synthetic minority instances, offering a more resilient solution compared to straightforward resampling techniques. Yeah.
For the final part, Mukesh will explain what the conclusion is.
So based on the results that we have got from the performance uh, Spark data set, we can say that SVM model has the highest accuracy. We have chosen accuracy because our data is a class imbalance data set. And also we are doing a classification problem which predicts whether client makes a default payment. So accuracy would be the perfect metric to do this. So SVM model has a greater accuracy than other models when compared. That's why we are choosing accuracy over here. Um, Next, I would like to hand over to Vinay.
Yeah. So this is the project we have done. We have gained so much insights like how we can do uh, this Python in the Pyspark regularly. Like traditional methods, we do like we download the Jupyter notebook and do some analysis in the Python. But this new way of doing this in the Pyspark has improved our knowledge. So yeah, that's it. I think. Thank you.
Thank you.
Thank
Thank you,
you.
everyone.
English,